So you want to create malware for your red teaming engagements. In this video, we're going to develop a simple but effective malware that is going to create a reverse connection from my Windows x64 box back to my Kali Linux box. First things first that we're going to have to do is create that shellcode. And what we see on the screen right now is just a MSFvenom command that tells us to generate the shellcode to execute a reverse shell back to my host, which is that .11, which is the Kali Linux IP address, and the port 4444. We hit enter, and we're going to get generated our code here, and we'll just go ahead and copy and paste it. So you copy and paste everything, and we'll move then to our Windows box where we're creating it in Visual Studio, this piece of malware. So we're going to just jump right over to that. I've already copied and pasted. I've created a shell, essentially main.cpp, and I started off with a shellcode variable, just dropped it, copied and pasted everything. What we're going to do here is we're going to start creating our shellcode. Or, excuse me, we've dropped our shellcode in. We're going to finish our malware to getting it to a working and effective sample. So let's jump right into it with getting what we need to go with. So pvoid shellcode exec equals VirtualAlloc, and I'll explain what each of these is here in just a second. Mem commit, mem reserve, page execute, read write. Finish it off with our semicolon. So what this is doing is going to the operating system and saying, we need some memory reserved for us. I don't care where it is. Just provide me some address that will be given back to this shellcode exec. So it's going to be a memory address. The size of is, we need it to be the size of our shellcode. This is how big we need the memory to be. Mem commit, mem reserve. It's a bit technical, but basically I want to reserve this spot and put stuff in it right now. Page execute, read write is basically the permission structure for that memory. And we're telling Windows that I want to have everything associated with it. I want to have read, I want to have write, and I want to be able to execute code from this block. And this is essentially what is going to bypass DEP, DEP. So we're going to go ahead, and now we need to copy that shellcode. And we're going to use this copy memory, which is really just mem copy. We're going to need the address that had been provided from us from VirtualAlloc. We're going to need our shellcode, and we'll need the size of shellcode. Again, this is just a copy memory operation that does exactly what it sounds. Our destination, what we are copying into it, and how much we're copying into it, how much data. And so after this line is executed, our shellcode will be sitting in that brand new memory space that's been set as execute, read, write. Our next instruction that we need to do is going to be actually getting a thread. So we're going to go dword thread ID. Now, we need to be able to execute this. It's sitting in memory. But no execution. It's just going to sit there. It needs some type of worker. We need to point and say, hey, worker, go over and execute what's in this newly allocated area. Do what is basically there. And so this is what this CreateThread command is doing. And let's see. After 0, we need to have the pthread start routine shellcode exec null 0 and the address of our thread ID. All right. So again, we're pointing at the space and we're saying, hey, worker, nothing is running it yet. Go to the area in memory and do what's there. So handle hthread is our variable to control the thread, thinking of it as the worker ID. This pthread start routine is essentially casting our memory address shellcode exec as a function, and we're telling that new thread, here's that starting, or your starting instruction is at this address. These are just default settings, null and 0. The instant this line runs, our shellcode starts executing in a brand new thread, and the connection back to that netcat listener will have occurred. Now, the one thing we do want is we don't want it closing right away. We want to still be able to potentially access. We're creating a reverse connection. We need to hold it open. And so what we're going to do is we're going to wait for single object. And we want to hold this open hthread for infinity or infinite, so that it's our shellcode it's running, but once it hits the end of the main program, it'll exit. So we need to continue running, and since our reverse shell is designed to never finish, it's going to cause the program to hang open. So what we have here, again, in summary, is we've taken our shellcode, copied it, made it x64, and the thing that we need to make sure of as well is that when we build and compile, that it's set for the correct architecture. If you run it initially in the 32-bit, it won't work. There'll be a memory access violation, so you'll want to make sure that is done correctly. And what we've done, we've taken the 4-step process that's needed to execute shellcode. We've created new memory with VirtualAlloc. We've copied the shellcode into that memory spot or the address that was just newly created with executable read-write commands. We've then created a thread to execute, to start running the code at the memory address of shellcode exec, and then we're waiting for it to, or keeping it open. So let's jump back to our Kali box and set up our netcat listener. Then we can come back, build, and we'll run it and check to see if we get a reverse connection. And it's important to note that this Windows box, Defender has been disabled, Firewall has been disabled. This is very simple malware development, but this is the base. You start building from the base, building out, then obfuscating, whatever. But let's jump over to our Kali box. Alrighty, back into our Kali box. I'm going to set up our netcat listener on our port. So NC TAC LVNP port 4444. We'll hit enter. Now it's listening. Next thing we do is we're going to jump back over to our Windows machine. And we're going to go ahead and build. And hopefully not get any errors. Build succeeded. This was awesome. We can disregard these little warnings here. This is saying it should be int instead of void. Doesn't really matter in this case because this is just for example purposes, but you could use the int main and return 0 afterwards. But we have built this correctly. Now let's go ahead and just run our program. So now it's running. And as you can see, it's waiting. So let's jump back to our Kali and hopefully we have a reverse connection. Alrighty. Back at our Kali Linux box, we see we have successfully received a reverse shell. We can go ahead and click on directory, see where we're at. And we are in the Windows box itself. We have successfully executed shellcode that created a reverse shell. If you found this useful, please hit that like and subscribe button because we're going to be building out. We're going to be obfuscating. We're going to be building additional malware development to really build on our red teaming engagements, building our red teaming tools out. Make sure to check out that next video that is here right now, and we'll see you soon.